Hello YouTube, and welcome to part 1 of my Intel Haswell overclocking guide for the 4670K and the 4770K i5 and i7 Intel Haswell processors. I've had quite the journey overclocking this CPU, the Intel 4770K. It's been unlike no other CPU I've had to overclock before. It's really taken a lot of time. I'm probably about 1 month and still have not found the best stable settings. However, I am getting very close. What I'm working on right now is getting my cache ratio up to a 1-to-1 ratio, currently running at 4.6 gigahertz and looking to run my CPU ring bus at 4600 megahertz, which is 4.6 gigahertz and is a 1-to-1 ratio with the CPU frequency. I've found a lot of problems getting it to 4.6 gigahertz with the CPU bus at the ring bus at a 1-to-1 ratio. What's really helped me a lot was increasing the CPU ring bus voltage as well as the processor input voltage. But I'll get more into that as we go along step by step through parts number 2, 3, and 4 of this overclocking guide. I would like to dispel a couple myths that are currently out there. One of the first myths that is conceptually out there from a lot of reviewers is that you may not be able to run your high frequency memory at its rated speeds with the Haswell platform overclocked aggressively. And by aggressively, they're talking 4.5 gigahertz or more. Through my testing on the 4770K, I have found absolutely no problems with running high frequency memory. Basically, I'm running a Kingston HyperX 2400 megahertz kit, Kingston HyperX Beast. For a full system overview of this test system, you can look for my Intel 4770K system overview video. It lists all of my hardware specs as per all of these tests will follow. So please look for that if you're interested in the entirety of my hardware test bench. Essentially, it consists of an Intel 4770K MSI Z87 M-Power Max motherboard, 16 gigabytes, that is 2x8 gigabyte Kingston HyperX Beast modules. XMP profile is rated at 2400 megahertz, 1.65 volts. I'll get into more of that later. I'm running a Kingston HyperX 240 gig SSD and a Silverstone Strider 1200 watt power supply, fully modular, with NVIDIA GTX 460 SLI. Also, I've got the SwiftTech H220 cooling the loop, and I've added an additional 120 millimeter radiator into the loop. So this was my first water cooling job. Once again, check out my system overview to have a look at the system and to get a better idea of what the system specs are. I would like to say something before I even begin, and that is I did delid my processor. I decided to take the integrated heat spreader off and replace the stock thermal interface material with Arctic MX2. Now, basically, Intel, there's a lot of hoo-ha about them not soldering the integrated heat spreader on. personally, I think all K series SKUs should have a soldered on integrated heat spreader, because who's going to buy these things? Enthusiasts buy these products. Enthusiasts don't want to have to void their warranty and possibly risk damaging their CPU in order to get the best possible clocks out of them. I mean, Intel should be encouraging the best possible clocks, unless that is their agenda, not to encourage such high performance. But, who am I to say? I'm just a consumer. I will say that the stock thermal interface material between the CPU die and the heat spreader is a very good material. It is designed to last for many, many years, and you will have consistent temperatures for many, many years. And this should be true about the stock thermal interface material. However, I saw a significant decrease in temperatures by removing the integrated heat spreader and replacing the stock thermal interface material with Arctic Cooling MX2, which is a non-conductive, highly thermal conductive thermal interface material, and I highly advocate Arctic MX2. Very, very good. So that being said, a lot of the temperatures that you will see through some of the next following videos while I'm stress testing are fairly low, because I have delidded my chip and I am running a semi-custom water cooling loop. So please bear that in mind. Your results will typically have higher temperatures depending on your cooling. Now, if you don't have a good aftermarket cooling solution, I suggest you save your money and buy one, or simply buy one now. Any good all-in-one dual radiator setup will be good enough for Haswell. For air cooling solutions, I cannot advocate Noctua NHD14 enough. That air cooler is the best, one of the best air coolers, hands down. Not only that, but Noctua will send you free mounting hardware in the future if you decide to change platforms and keep your Noctua heatsink. They are a very, very good company. They make some of the best, quiet, highest performing fans on the market. And if you're going air cooling, I suggest you pick up a Noctua NHD14. On the Noctua air cooler, I was able to hit 4.6 gigahertz stable. My temps were fairly high. I maxed at about 90 under artificial stress testing, but hey, that's not bad. Under the new loop, honestly, I could max at about 77, going from the air cooling stock thermal interface material between the die and the heat spreader. After I delidded and went to the custom loop, my max temps are now about 77, 78 under the same voltage scenario. So you can see right there, that is a 12 degree centigrade decrease in temps, simply by upgrading my cooler and delidding my chip. With that being said, let's move on into basically overclocking Haswell. Now, Haswell, like I said, is very, very, very difficult to overclock. You have lots of variables with the Haswell chip. Here's a few of the variables. First of all, you're trying to find stability with the CPU frequency. You're trying to find stability with the CPU ring bus, which can actually really hinder your entire performance if you don't know what you're doing. At first, my overclocks, I was only able to get a 3000 megahertz ring bus with a 4.7 gigahertz overclock, and that's fairly low. I mean, the ratio is really off. 4.7 gigahertz CPU frequency and only a 3000 megahertz ring bus. I was able to bring my ring bus frequencies up by doing a couple things: by increasing the processor input voltage, also known as the VCCIN, and by increasing my CPU ring bus voltage. Both of those voltages are very, very finicky require very finite adjustments to find the best possible setting. So that will take time, and if you're not willing to commit that time, you can just basically go for the quickest, easiest overclock you can possibly manage and be happy with that. So overclocking the Haswell CPU, the first thing we do is we find the best possible CPU frequency. Now we're going to start this guide at a frequency of 4.4 gigahertz for a couple reasons. First of all, it's fairly safe to say that all Haswell chips will hit this. Second of all, not everybody has a good cooling solution. I know a lot of you guys have air coolers that are worth maybe $50 or less. And let's be honest, if your air cooler is worth $50 or less, you're not going to be getting the 4.6, 4.7 gigahertz without basically overheating your chip to the point that it throttles down. Now, none of my overclocks would ever suggest having a CPU throttle down. We're going to basically shoot for a maximum CPU temperature of 85 to 90 centigrade. We can safely hit about 94 to 95 before the CPU throttles down. But for synthetic benchmarking purposes, we're going to keep 85 to 90 as our absolute maximum that we want to hit. So the first thing that we do is we're basically going to find the best CPU frequency and I'm going to base this guide off of 4.4 gigahertz. The next thing we're going to do is we're going to find stability with the highest CPU ring bus. Now, the ring bus is really tricky. If you're having problems at all, I would say drop this ring bus down to 3000 megahertz or a multiplier of 30 to find the best CPU frequency, okay? Now, I'm going to base this guide with a ring bus of 3900 megahertz because I think it's imperative to bring the ring bus up to a 1-to-1 ratio as soon as possible, and I think a lot of the default parameters on most motherboards will allow for you to run 4.4 gigahertz with a ring bus of 3900 megahertz. The ring bus, like I said, takes a long time to figure out, and through my testing, hopefully I'm going to save you guys some time by giving you my best suggestions. The third thing we're going to do is we're going to find memory stability. Now, memory stability is so important for a couple reasons. First of all, XMP profiles are misleading. There is no guarantee that your kit will run at an XMP profile. Extreme memory profiles are basically considered overclocking. So if your memory is rated to run at 1600 megahertz and 1.35 volts, that's great. You can contact the manufacturer and basically figure something out. But the reality of it is that memory is based off of a JEDEC standard, and the JEDEC standard is what your memory manufacturer will support. Anything else, including XMP profiles, are considered overclocking. Now, I'm going to help you get your memory up to its rated specifications, whether it's 1600, 2133, 1866, 2400. We're going to do that. It may require more voltage. That is basically the only thing, and that is only for high frequency memory. I can guarantee when we go through the memory stability video, you will see that Haswell is very capable of running high frequency memory. The last thing that we're going to do while we're overclocking the Haswell chip is we're going to enable the power saving features. Haswell has tremendous power saving features while you're just idle surfing the internet. The CPU frequency should drop as low as 800 megahertz with a core voltage of about 0.7 volts. As you may know already, Haswell is fairly jumpy, so that 800 megahertz will, be in the range of 800 to 2 gigahertz, 800 megahertz to 2 gigahertz of a voltage range of 0.7 to 0.9 volts, and it's jumpy and it jumps around a lot. But overall, the average is very consistently low, right? So we'll get into enabling the power saving features of your Intel Haswell chip as well. Now, this guide pertains to the 4670K and the 4770K. Keep something in mind. The Intel i5 4670K is basically identical with the exception of hyperthreading. Hyperthreading requires more voltage to the CPU. It actually generates more heat as well. So what that means is i5 users will typically need less voltage to achieve the same frequencies. Here's an example. For 4.6 gigahertz on an i5, you are probably in the range of 1.25 to 1.3 volts. For a 4.6 gigahertz overclock on the i7 4770K, you are probably in the voltage range of 1.28 volts to 1.37 volts. In that range. It's really widespread of how many volts your CPU is going to need. If you follow my guide step by step, you will find that we're going to eliminate the variables. We're going to eliminate the CPU ring bus causing us problems. We're going to eliminate the memory causing us problems. Once we isolate those variables, so there's a set standard, we can go ahead and basically find the best possible CPU frequency for our Haswell chips. Now, the first thing that I'm going to recommend is that you install the latest official BIOS for your motherboard. Go to your motherboard's website, download and install the latest BIOSes. There are instructions on how to do this, BIOS or UEFI, whatever you want to call it, you know. Go and download the latest official BIOS, get that installed, so we can basically, your CPU microcode, we know that that's been updated to the latest standard. The next thing that I'm going to have you guys do after that is we're going to clear the Cmos, and that's going to tell me that, you know what, all of your default parameters are set to default. The last thing I need you to do is to be going in there and changing stuff. You need to follow this guide basically step by step. If you don't, if you start working on your memory and your ring bus at the same time, you're going to basically find yourself getting nowhere fast. You need to isolate those variables as being stable and not a problem. Okay? So, once again, follow this guide step by step. So we're going to clear the Cmos, then we're going to change the CPU multiplier to 44. We're going to change the CPU vCore voltage to 1.25 volts. We are also going to change the processor input voltage indicated by VCCIN by most motherboard manufacturers. We're going to change that value to 2 volts. Now, you don't necessarily need 2 volts, okay? We're just going to basically put that out there because I've seen a lot of people having issues even hitting 4.4 gigahertz without changing that value. I personally know when we try to increase the CPU ring bus, having that 2 volts going into the processor is imperative to finding the best possible CPU ring bus. Once we find the best possible CPU ring bus, we're going to start to actually bring that voltage down to the lowest we can while maintaining proper stability. Next, we're going to set up our RAM for 1333 megahertz at 1.5 volts. You really need to follow this step. If you deviate from this at all, chances are you're going to find instability once again. We need to isolate the memory as best as we can as not being a problem. So what I'm going to have everybody do is set the memory for 1333 at a voltage of 1.5 volts. If you're concerned that your memory is only required to run at 1.35 volts, that is typically a XMP suggestion. It's not a JEDEC standard, okay? Most DDR3 kits are meant to run at 1.5 volts to 1.65 volts. If you can run your RAM at any lower than that, that's awesome. And we're going to work on that later because we would like to see you bring all your voltages down to as low as possible while maintaining stability. The last thing we're going to do basically, after we change all of these parameters, we're going to boot up and we're going to test with the Intel Extreme Tuning Utility. Now this is the only stress test that I think is really valid right now. You can use AIDA64 for stress testing. I do not like it for a couple of reasons. If your CPU core voltage is not set to manual, which I have not told you to do because we are using the IETU, if that value is not set for manual while stress testing with AIDA64, AIDA64 will overvolt your CPU, meaning if we set that voltage for 1.25, it may go as high as 1.38 volts. We do not want that. The Intel Extreme Tuning Utility does not overvolt your CPU under any circumstance. It's manufactured and produced by the same company that manufactures and produces your Intel CPU. So it is the best stress testing program for the Intel Haswell platform. All of your old CPU stress testing programs, I'm sorry, throw them out the window right now. They're gone. Prime 95, OCCT, get those out of here. For the Intel Haswell platform, you need to stress test with either the Intel Extreme Tuning Utility or AIDA64. And we are going to be using the Intel Extreme Tuning Utility. I will put a download for the program in the description section below. With that being said, we're going to go right on in ahead and talk about stability testing. Now, the entirety of this overclocking guide is based off of a minimum 8-hour stress test. If you cannot get your computer stable for 8 hours while stress testing, you cannot follow the rest of this guide, so you may as well just shut her down and go home now. I find personally a minimum of 8 hours is required for any overclock to determine stability. For my own systems, I run my stress test for a minimum of 18 to 24 hours before I will validate the overclock as being stable. So for a bare minimum, I strongly suggest 8 hours, and the entirety of this guide will be based off of an 8-hour stress test, okay, using the Intel Extreme Tuning Utility. So basically, you're going to start stress testing at 1.25 volts. If your system crashes, you're going to have to start increasing your voltage. Remember to follow step by steps all the instructions that I've provided so far, okay? Start increasing the voltage, 1.26, 1.27, 1.28, 1.29 volts. Now, I don't suggest going past 1.29 volts for 4.4 gigahertz. However, you can if you do decide to, and you do have thermal headroom to do such a thing. You should not be exceeding 85 to 90 C maximum as a maximum temperature, okay? Use core temp, or the Intel Extreme Tuning Utility also displays a minimum, maximum, and average CPU core temperature. So that is also very good for monitoring your CPU's vital statistics. Now, if, for example, you're stable at 1.25 volts and you followed everything step by step as I explained, what you can start doing is start dropping the voltage. I, for example, only need 1.23 volts to be stable at 4.4 gigahertz. You may need as low as 1.2 volts. It's really dependent on your CPU and how well it performs. So if you are stable at 1.25 volts, go the other way and start reducing the voltage. Okay, find the best possible lowest voltage that your computer will be stable for 8 hours with. And hopefully you don't have to exceed 1.29 volts to find stability at 4.4 gigahertz. I cannot stress enough, don't exceed 1.5 volts for any overclock on the Intel Haswell CPU platform. I have found through my own personal testing, for the 1 to 200 megahertz you're trying to get, it's probably not there. It probably doesn't exist. You may be able to benchmark. You're not going to find any stability. I've ran my chip as high as 1.48 volts and it gets ridiculously hot even on a delidded chip. I do not recommending going any higher than 1.45 volts, but certainly do not exceed 1.5 volts for any reason whatsoever. The temps for your stability testing should not exceed 85 to 90 centigrade maximum. Basically, that's the maximum temperature. Haswell is very jumpy. If you can see an average of about 80 centigrade, that is basically where you want to be comfortably. An average of 78 to 80 for a maximum comfort zone. Once you start exceeding that zone, you're just basically running into trouble with having any available thermal headroom because you've maxed it out. Certainly I do not want to see you go past 94, 95, because what happens then is your processor will start to throttle down. It may even spike to 100, and it will start decreasing the voltage, decreasing the frequency to basically protect itself. It's getting too hot to run, basically, so it will start to throttle down. A proper overclock should never throttle down. You should be running, above average, close to your maximum thermal envelope, and but certainly not very close to it that you're going to start exceeding it or meet it. So the 75% of maximum rule basically applies. So for people wondering how to push past 4.4 gigahertz at this point, really it just means increasing your voltage, okay? These are my most stable results that I've been able to get past 4.6 gigahertz. Right now what I'm trying to do is push for a 1-to-1 ring bus ratio. But you can see here on the screen, I've taken as much as 1.35 volts to hit 4.6 stable for over 20 hours with a ring bus of 4500 megahertz at 1.3 volts, and the processor input voltage, which is VCCIN, I had to change that from default to 1.9 volts. Same thing with the 4.7 gigahertz overclock. Now the only reason I had to change the processor input voltage was to bring up the ring bus and get that stable. But that will be in part 2 of the overclocking guide. Right now, basically what I want you guys to do is follow step by step all of the information that we've gone through, and I'm going to show you exactly how to do it here, other than installing the latest BIOS, which I have already installed the latest official BIOS from MSI for my motherboard. So what we're going to do here is we're basically going to restart and boot into the BIOS, or U8FI. Now, I also had mentioned to clear the Cmos as step number 1. So you can either clear the Cmos, or what you can do is load the optimized default values. As part of this overclocking guide, I need to make sure that all of your values are set for default. So what I'm going to do is basically load my default values here and go ahead and restart the system and boot back into the BIOS again. So either clear your Cmos and make sure all of your values are set for default, or load the optimized defaults. Typically this is F6 when you're in the BIOS. BIOS here, and remember, once again, follow this guide step by step. Only change these values. So we're going to set our CPU ratio for 44, like I said to begin with. The next value we are going to change is our RAM frequency, and we're going to see I've already set that manually for 1333, so we want that set at 1333. The next thing we want is our CPU set at 1.25 volts. Now, you may need slightly more voltage, you may need slightly less voltage. This is just a good baseline, I think, to start with. If your computer starts to crash at this voltage, start increasing it 1.26, 1.27, 1.28, 1.29 until you find stability. If you can boot and stress test all day long at this voltage, let's start increasing that. Get that down as low as you can, as long as you can run a stress test for 8 hours. The last thing that we're going to do is we're going to change our memory voltage to 1.5 volts, and that's it. So we've changed our CPU frequency, we've changed our DRAM divider, set it for 1333, we've changed our CPU voltage, and we've changed our memory voltage, and that's basically it. So next thing you're going to want to do is hit F10, save your configuration, and boot back in to Windows. And keep the camera a little bit closer so I can just show you that the CPU is indeed hitting 4.4 gigahertz at 1.25 volts. So once again, I will be using the Intel Extreme tuning utility. Now I use this to I can make finite adjustments through the All Controls tab. Let's just see here. I can make small adjustments while I'm trying to find ring bus stability, but that's really all I choose to use it for. So this is going to be pretty difficult to see. Okay, so there you go. CPU-Z, we booted back in. Don't mind the core voltage that you're seeing right there, because it's not displayed accurately. I'm going to show you the Intel Extreme Tuning utility that shows my voltage very accurately. So you can see we're at 4.4 gigahertz now. We've just booted back up. Moving over to the Intel Extreme Tuning utility there. That also shows us, it shows 4.5. I'm not sure how accurate that is, but you can see our voltage is at 1.25 volts, 1.252, but I wouldn't worry about that. I always see slight variances of up to 0.002 volts. Nothing to be alarmed of, nothing to be concerned about. Okay, so what I'm going to do next is start the stress test. And the stress test is up in this corner here. Please forgive my camera. So I'm going to start this stress test. And I'm just going to set it for 2 days. That's what I set it for. Now once again, we're only looking for 8 hours of stability. And I'm going to go ahead and start stress testing that. Now, right away you can see CPU's at 4.4 gigahertz. My voltage is at 1.252. Like I said, don't worry about that 0.002. This is the Intel Extreme Tuning utility. You can set these parameters however you like them. I like to set my my total TDP as well, see what kind of watts this thing's drawing, and how the temps are reflecting that, which I should actually have up here. And I'm going to go ahead and set the CPU. Oh, I've already got it up. Yeah, you can see my temperatures at this range are extremely good. Like I said, I'm on a custom, semi-custom water cooling loop, and I've delidded my chip, so my temps are extremely ridiculous, and you can see my CPU utilization is 100%. If you would like some more validation, I'll just bring up the Windows Task Manager here. And you can clearly see that all the cores are being stressed right now. So there you go. Part 1 of the overclocking guide. Part 2, we're going to work on bringing the ring bus frequency up, which is currently set at 39, which you can also see in the Intel Extreme tuning utility here. Right here it tells you a lot of good information, your core voltage, the ring bus ratio, offsets, that kind of thing. These are all values that you would define in your motherboard BIOS. You can also sometimes define them through the Intel Extreme tuning utility. However, I always choose to define these values manually through the BIOS for best results. So thanks for watching. Stay tuned. Check out part 2, which will be the CPU ring bus overclocking guide. Then we're going to move on bringing our memory modules up. Right now I've got a 2400 megahertz kit clocked down to 1333, but I need to eliminate all the variables in order to find CPU stability. Thanks for watching my video, and look forward to seeing you on the next one.